Good afternoon, everyone. My name is Yinggang. I'm from Shanghai Jiaotong University. I'm very honored to present our work, ShopEye, fusing RFID and smartwatch for multi-relation excavation in physical stores. Shopping behavior data are of great importance to understand the effectiveness of marketing efforts. Online stores are capable of capturing customer shopping behavior by analyzing the click string and the customer shopping cart. However, retailers with physical stores still lack effective methods to identify comprehensive shopping behaviors, and traditional methods like employee observation, intercepting surveys are labor-intensive and cannot be performed frequently. There comes many benefits if we can obtain customer behaviors in retail stores. For example, retailers can understand the interests of the shopper and they can send targeted ads to shoppers. The behavior data can serve as shopping logs for customers, and they can look back their shopping experience anytime. Moreover, we can even enable automatic checkout based on customers' behavior in stores. Existing methods face various problems. Computer vision-based methods require high computational cost and fail to work in bad lighting conditions. And RFID-based methods are environment sensitive. Also, they cannot obtain the customer information, so they cannot provide personalized information. Mobile devices-based methods use smartphone or smartwatch to track customers and detect their behaviors, but they cannot obtain the item information. There comes with many benefits if we can obtain customer behaviors in. Motivated by the limitation, in this paper we present our solution, ShopEye, a hybrid RFID and smartwatch system to enable physical analytics of retail stores in an implicit and non-intrusive manner. In recent years, many retailers have deployed RFID technology for inventory management, and the smartwatch becomes increasingly popular among people. We focus on revealing three kinds of relations, which can offer physical analytics on all dimensions. User item relation refer to interest that a customer has for a given item. Collecting such kinds of data allows retailers to better understand customers' shopping preferences. User-user relation represents social relations among customers and enables retailers to provide group-level recommendations, such as buy 2 items and get 1 extra promotions. Item-item relation includes positive and negative correlations between items. The positive correlation means that customers buy or show great interest in 2 items together. The negative correlation means there is a competition between 2 items. The figure shows typical customer behavior in store. People walking into a store and they may pick up an item and then examine it carefully. And they may put it back to the shelf or take it away. During this process, both the signal from the item's RFID tag and the inertial signal of customer's smartwatch can capture the user-item interaction. We leverage this to recognize customer behaviors. This is the system workflow of ShopEye. The system first performs user-item pairing and then performs the other 2 pairing according to these results. As a rule, user-item interactions behavior begin only when customers stop walking, and thus the first step of ShopEye is to perform walking detection. due to the diversity of the customer working pattern in storms. We detect working with the acceleration among gravity, which is insensitive to various arm or body movements. When a customer picks up an item, he may flip over the items to have a full view, or carefully read the product information. During this process, the micromotion pattern of the smartwatch and the RFID tag attached to this item should be consistent. We explore these insights for user item pairing. Before the motion pattern matching, we first spot the gesture which may be customers picking up gesture. Then, when the customer reaches the hand for picking, the net displacement of a smartwatch shouldn't be too small. We use quantiums to compute the net displacement. We assume that the position of elbow remains stationary during this process. When the displacement is larger than a threshold, the gesture is regarded as a candidate gesture. We also select the candidate tags according to the signal phase of RFID. Observe that the raw motion data from the smartwatch and the RFID cannot be directly matched. We need to map them to a common alphabet. In this work, we map the signal to a binary state only involving moving and stationary. We identify the motion state of the smartwatch by computing the entropy of acceleration signal. We explored the Jagged index to estimate the similarity between the sequences and find the most possible paired sequences. For the user-user relation, we borrow the idea that customers in a group can be clustered by their motion behavior similarity. We construct 4 binary time series: walking and stopping, turn, walking upstairs, and walking downstairs. We evaluate the motion behavior similarity between 2 customers by calculating cross-correlations between their time series. We also exploit the recognized user item pairs to discover the item delivery between customers, which can notably boost the group detection accuracy. We recognize the item-item relations based on the user item pairs. We evaluate the ShopEye in our lab environment. We deployed 4 shelves in this room and display toys, books, clothes, and snacks on each shelf. 10 volunteers was recruited to mimic customer in retail store. We conduct 4 sets of experiments in uncontrolled scenarios to evaluate the applicability of our system in real settings. The number of volunteers in the experiment is 4, 6, 8, and 10, respectively. From the figure, we can see that the recall and precision return around 19% when there are 10 people. The left is the group detection results. Result boosting means we detect customer groups only by the similarity analysis of motion behaviors. We can see that with user item information, the accuracy can be increased significantly. The right is item-item relation. We can also achieve more than 90% accuracy. As a conclusion, we present a hybrid RFID and smartwatch system to delve into 3 relations in an implicit and non-intrusive manner. And we evaluate the system extensively in our lab environment, which mimics the real retail store. In the future, we plan to borrow the idea of crowdsourcing to enhance our system. And for example, Nowadays, nearly every customer carries smartphones when shopping. We can construct the product layout by fusing the information from smartphones, smartwatches, and RFID tags. Then we can employ smartphones and RFID tags to infer customers' behaviors if they do not wear the smartwatch or pick up items using the hand without smartwatch. That's all of my talk. Thanks for listening.
Well, because in a real store, I mean, you have many people. Do you think that this kind of approach can work in a real context where there are many interference between people, sensors, devices, and so on?
Yeah.
When you did the test in the laboratory, I mean, there are only one user per time, or a group of users?
A group of users in the lab environment test to environment our system to detect the group. If they are in a group. Nearly 2 or 3 people picking up some things. But I think it is our first attempt to fusing the RFID and the smartwatch to delve the three kinds of relations in the physical storms, because in online storms we have some other information.
So, okay.
Hi, thank you for your talk. I really enjoyed it. So I just wondered during your evaluation, exercise having observed items scenarios specific candidate. For example, if the user try to pick out some products like this, rather than some very possible products like some food collectibles, is there any difference?
I think so your question is the different things is they are equal in our system?
For example, if the customer tries to pick out different items, are there any differences?
They are pick up 2 items in the same time or in different time? Different time. So can you?
Different types of items, and you see a difference in your classification for, say, big items or small.
Yeah. It is different. It is different.
How is it different in your application? How do you detect that there are different types of objects?
Because every item attached an RFID tag, and the RFID tag is with ID.
Can you consider that people usually wear smartwatches on their non-dominant hand, so they are used to pick the object with the hand without the watch?
I have talked this question in there, and in our system we can use the primary hand to detect these gestures, and in the future we plan to follow some idea of cross-sourcing, like so if you carry a smartphone, you can use this system same.